Okay, this is the third sample final for Math 2B. Let's get started right away. This first one is about Riemann sums. It asks us to estimate the area under the curve using a Riemann sum with 4 subintervals and midpoints. Sketch the Riemann sum by drawing rectangles on the picture. Okay, so the width of the rectangle, remember how we get that? That's b minus a over n. That's our delta x. Okay, delta x is the width of our rectangle. B is 8, a is 0, so 8 over n is the number of rectangles or subintervals, so 4 rectangles. So each rectangle would have width of 2. Okay, and then we're using midpoints. So in this particular case, for this point, we have an interval from, okay, backtrack. We have an interval here, 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 and here for our 4 rectangles. Within each interval, we're going to use a midpoint. That's what it asks. Midpoint would be, in this interval, would be 1. So we draw a rectangle like this. Okay. From 2 to 4, the midpoint is 3. So we will do something like this. 4 to 6, the midpoint is 5. 6 to 8, the midpoint is 7. This would be our Riemann sum approximation. Okay, the area of these 4 rectangles. So let us estimate. So it'll be 2 times f of 1, which is let's estimate that as 3 over 2 plus 2 times, so I factor out the 2. All the widths of the rectangles are 2's. Right, 2, 2, 2, 2. So I factor that out. The height of this rectangle is, let's say it's 4. Height of this rectangle is, let's say it's 3. Height of this rectangle, let's say it's 3 halves. Okay, this is just approximation. See, this is technically a bad question because if you don't do 1.5 like they guess you would, if you do, like, for example, 1.3, then they'll throw off their grading process. So this is a bad question for them. That's their problem, if so. Anyway, so if you don't do 1.5, you could argue against them too. Anyway, instead of 1. Okay, I'm going off topic. Let's continue. All right, this is what? 7 plus 2 3/2, so that's 10. So 2 times 10, this is 20. Okay, this is a good estimate for this Riemann sum, this integral. Next, evaluate these integrals. First one is a trig integral. That's obvious because we have sines and cosines. We see we have an odd power for sine, so we want to save that. And then everything else we would change to cosine. There's nothing else to change, so we let u be cosine theta. du would be minus sine theta, d theta. So our integral becomes u squared du with a minus sign in front. U squared minus du, so I pulled the minus 1 out. This is minus u cubed over 3 plus c, which is minus cosine cubed theta over 3 plus c. Okay, that's our answer. Next, this one, it's most likely partial fractions. Okay, so we can, actually, is it partial fractions? Let me see. Yeah, it probably is. Except the, let me see. If we break up this integral into x. What's a good way to do this? That's I'm thinking. Because if we separate this integral into x over these two terms minus 7 over these two terms, x squared, we can't do a u sub for that first one. So I'm now thinking, can we do, because this had to be a product of two things. Actually, can we just do it the normal way? A over x plus 1 plus b over x minus 3 is equal to x minus 7 over x plus 1, x minus 3. Maybe I was overthinking. Okay, let's just try it like this first. So if we multiply both sides by this denominator, it'll be a x minus 3 plus b x minus x plus 1, is equal to x minus 7. The quick way to solve this, if x is equal to 3, then this guy would go away. We get 4b is equal to minus 4. So b is equal to minus 1. X is equal to minus 1. Then this would go away. We get minus 4. A is minus 8. So a is equal to 2. I guess this normally worked. So I was just overthinking it. Okay. So we can rewrite this as the partial fractions. 2 over x plus 1 minus 1 over x minus 3 by dx. Okay, so this is easy. They're just both logs. This is good enough. Okay, let's move on. Average value, this should be very easy. Okay, remember how we find average value? Oh, the way to find average value is easy, but the integral might not be as easy. Anyway, remember how we find average value is 1 over b minus a. Whoops. 1 over b minus a, integral a to b, f of x dx. Okay, so in this case, it would be integral from 0 to pi over 2 of x cosine x dx, and in the front would be 1 over pi over 2. Okay? Times. Let me write it like that. This guy, how do we solve? Whoops. This should be quite obvious. It's integration by parts. Okay? So we let u be what? Which one? Will be x. Du would be dx. dv is cosine x. dx. b would be sine x. Okay? So this guy is equal to 2 over pi times, I just flipped that. This integral is uv minus v du x sine x, evaluate from 0 to pi over 2, minus integral 0 to pi over 2 sine x dx. Okay? This is simply just, let me go here. So let me kind of dot that. Box that, I don't know what the term is. Okay. 2 over pi x sine x. Integral of sine is minus cosine, so it'll become plus cosine x. Evaluate this whole guy from 0 to pi over 2. Okay, so we get 2 over pi times, when x is pi over 2, we get pi over 2 times sine pi over 2. Sine pi over 2 is 1, so we get pi over 2 plus cosine of pi over 2 is 0 minus, we plug in 0, this first term would be 0, and then we get cosine of 0, which is 1. Okay? So this is 2 over pi times pi over 2 minus 1. You can write that as pi minus 2 over 2. Okay. Do we need to simplify this further? Should I just simplify it further? No, why don't I just do this? Let's distribute this 2 over pi. It'll be 1 minus 2 over pi. This should be good enough. Okay. Next, particle has velocity, this guy, at feet per second at time t seconds. Compute the displacement of the particle over the time interval t equals 0, t equals 3. Okay. I don't know what this, is this graphing this? I guess so. Okay, anyway. Displacement of the particle over the time interval 0 to t. Displacement is just change in position, so integral v of t dt from 0 to 3. Okay? So that is integral from 0 to 3 of 2 to t minus 5 dt. This is integral, if we can evaluate there. What's the integral of 2 to the t? It's just 2 to the t divided by ln 2. Okay. Minus 5t, evaluate this whole thing from 0 to 3. Okay. So this is simply just 8 over ln 2 minus 15 minus parentheses 2 to the 0 is 1, so 1 over ln 2 minus 0. So this is 7 over ln 2 minus 15, and then the units would be feet. Okay, that's how we solve this one. The distance traveled by the particle over the same time interval is given by integral from 0 to a, 5 minus 2 to t dt, plus integral from a to 3, 2 to t minus 5 dt. This is the total distance traveled, okay? Where a is a constant, what is the value of a? So essentially we were trying to find 0 to 3 absolute value v of t dt, that's the total distance traveled. Okay, so they broke up the integral. Why? Because they want to flip this negative portion into the positive. Over here it's positive from some value a, so this value here is a. From a to 3 is positive, so they kept it the same. Okay, but from 0 to a, they took the minus v of t, so that's 5 minus 2 to t. What is the value of a? How do we do that? That's when v of t is 0, so v of t is this guy. We need to set that equal to 0. 2 to t minus 5 is equal to 0. Okay, so we solve for t, where it's 2 to a, it would be, because that's when t is equal to a. Okay, so 2 to the a is equal to 5, so a is log base 2 of 5. Okay, that's how we do that. Log base 2 of 5 is a. That was easier than I expected. Okay, let's move on. Oh look, it's probably area and volume. Region R is drawn. Find the area of R. Okay, remember area is upper curve minus lower curve. So we can integrate with respect to x. If we do, that's from 0 to 1. Okay, upper curve is the parabola, 1 minus x squared. Minus lower curve, it's the straight line, 1 minus x all by dx. This is integral from 0 to 1. This 1 and this minus 1 would cancel. We get minus x squared plus x. I believe that's correct. Dx. Okay, so this we can simply do the power rule, minus x cubed over 3 plus x squared over 2, evaluate from 0 to 1. We plug in 1, we get minus 1/3 plus half, plug in 0, both of them would be 0, so this is what? Minus 2 over 6 plus 3 over 6, which is a 6th. Let me check that's the answer. Yes. Set up but do not compute an integral for the volume when r is rotated around the line x is equal to minus 2. So x is equal to minus 2. Let's go back here. Our axis of rotation is over here. X is minus 2. We're rotating about this guy. Okay? So we have to draw, or I draw my representative r out and r in. Okay? So remember the volume is pi integral r out squared minus r in squared. Because this is a vertical axis that we are rotating against, it'll be dy by the washer method, okay? The limits of integration, it's dy, so in terms of y, it'll be 0 to 1. In this case, the x would be the same, but we're choosing y, so I want to show that. 0 to 1. What's r out? Okay, let's flip this. Let me explain it once again, if you don't get it by now. We know that from this point here to this point, okay, so first of all, r out is the longer one, r in is the shorter one. R out, what's the length of r out? We know that from here to here, so what I just drew in blue, that length is 1 minus x squared. Okay, we want it in terms of y, but let me explain. This is 1 minus x squared. That's the length. We have this additional length of 2. So it's 2 plus 1 minus x squared. Okay? And similarly, over here, this length here, from this axis to this point, is 1 minus x. Okay, so we have an extra length of 2, so it would be 2 plus 1 minus x, okay? So hopefully you got that. Let us change these guys to be in terms of x, though. X in terms of y. This one's easy. That's just x is equal to 1 minus y. Okay? What about this one? It'll be x squared is 1 minus y. X is square root 1 minus y. Is it plus? Is it minus? Because we get a plus or minus. Which one is this one? We can plug in x is equal to, well, actually, when we plug in x is equal to, or y is equal to 1, we would get x is 0. When we plug in y is 0, we get x is 1. What about when we plug in y is minus 1 over here? We would get, does that help? I'm trying to see which one it is. What would get us this side of the curve over there? Because that would be minus. Actually, you can think of it another different way. This is the positive y. This is the positive x. So this guy is always positive. When x is 1, y can only be, actually, yeah, when x is 1, if we look in there, x is 1, y has to be minus, y has to be 0. So then when x is minus, yeah, so when x is minus 1, what's the value of y? It would be 0 also, but we need a minus sign. Yeah, so this guy is correct, okay? That took way too long, okay? So it's when you square root, it's plus or minus, we know we're taking the plus for this curve, okay? So, where were we? R out. We said it was 2 plus this length, the blue over here, which is square root 1 minus y. So it's 2 plus square root 1 minus y squared. That's r out squared minus r in is 2 plus, this is 1 minus y. 2 plus 1 minus y squared all by dy. Okay, that's it. That's all we need to do for this problem. This one, compute this integral. This looks like a trig sub. Why do I know that? Because it's something squared plus something squared, and this is technically a square root cubed. Okay, so let's set up our triangle. Okay, we know that this is something squared plus something squared, so we know that these two have to be sides, and this guy, 9 plus x squared, has to be the hypotenuse. Okay, so we want to sub everything in this integrand in terms of theta, so we will need to get x in order to get dx. So let's get x first. How do we get x? Tangent theta is x over 3, so 3 tangent theta is x. 3 secant squared theta d theta would be dx. Okay? And then we can get square root 9 plus x squared cubed. That's this guy. Okay? That is, what's square root 9 plus x squared in this? It would be secant theta is square root over 3, so 3 secant theta is the square root cubed, okay, which is 27 secant cubed. Okay, so we substitute everything in this integral in terms of theta. Let's pull the 9 out. Okay, so we get a dx on top, which is, we got here 3 secant squared theta d theta over the bottom, which is this term, which is 27 secant cubed theta. Okay, 9 times 3 is 27. That would cancel with the 27 on the bottom. This secant squared divided by secant would be a secant on the bottom, which we can move as a cosine theta d theta. Okay, this is very easy to solve. That's just sine theta plus c, and then we have to back substitute theta. Go to a triangle. Sine theta is x over square root plus c. That's our answer. Very easy. Okay, let's move on. So, as a side note, notice how I knew all the calculus except when what took forever for me was a more fundamental thing. So I much prefer the calculus over algebra and all that. Okay, you're given the following information about a function f. We have f of 0 is 5, f of 2 is 3. Integral from 0 to 2, f of x dx is minus 1. Compute these guys over here. Hence, you may find it convenient to use techniques like substitution or integration by parts. Okay? This first one, let's rewrite it as integral from 0 to 2, 3 f of x dx plus integral from 0 to 2, 4 dx. Okay? This we can pull out the 3, so it'll be 3 times integral from 0 to 2, f of x dx. We have that here, so it'll be 3 times minus 1 plus 4 times 2, because this will be 4x, evaluate from 0 to 2, and then we plug in x as 2 for the upper bound, and then minus x as 2 as the lower bound, so 2 minus 0 is 2. This is 8 minus 3, which is 5. Okay, this guy, integral from 0 to 1, f of 2x dx. Let's let u be 2x, du would be 2 dx. So our integral would become, we have to change the limits of integration. When x is 0, u is also 0. When x is 1, u would be 2. So we would get f of u du with a half in front, because it'll be du over 2. This guy would just be half times this we are given here. It's just one's in u, one's in x. Half times minus 1, which is minus half. Okay? This guy, they gave us hints that we might have to use by parts. This one probably is by parts, okay? So we need a u and a dv. How do we choose which one? Okay? We are given integral from 0 to 2 f of x dx, so I'm thinking we should put our dv as f prime of x dx. Because when we get a v, it'll be f of x, and then we have a v du integral later. So let's see. Du would be dx. V is f of x dx. Oh, no dx here, sorry. So integration by parts, we would get what uv minus v du x, f of x, evaluate from 0 to 2, minus integral from 0 to 2, f of x dx. Yep, so this we were given as minus 1. This, on the other hand, will be 2f of 2 minus 0. After we do fundamental theorem of calculus. Then minus, this was minus 1. So this is 2f of 2. F of 2 is 3. So it'll be 3 plus 3 times 2, sorry, plus 1, right? F of 2 we said was 3, so 2 times 3, yes, plus 1, so that would be 7. Okay, that's our answer for that. Okay, I'll stop here for this part.